Good morning everyone. Welcome to today's maths class. Let us continue the chapter pair of linear equations in two variables. Okay. So we have learned that the general form of a linear equation and the general form of a pair of linear equations in two variables. Okay. Now any point on the given line of an equation is the solution for the equation. Okay, we know that. Then what is the solution for a pair of linear equations? So in this chapter we are going to learn how to find the solution for the given pair of linear equations. Okay. Now first of all, what is the general form of a pair of linear equations? Now look at this. The general form of a pair of linear equations is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Okay, this is a pair of linear equations. Now, how will be the solution of a pair of linear equations? Okay, it depends upon the equations actually. Now, let us take one example of a pair of linear equations. So, let us take 2x plus 3y minus 6 is equal to 0 and 3x plus 5y plus 3 equal to 0. Here there is a pair of linear equations. Look at this. 2x plus 3y minus 6 is equal to 0 and 3x plus 5y plus 3 is equal to 0. Let us compare the coefficients of x, y and the constants. Okay. Now, a1 and a2. What are a1 and a2 from the given equations? 2 and 3. So, a1 by a2 is equal to 2 by 3. What is b1 by b2? b1 by b2 is equal to 3 by 5. And what is c1 by c2? Is minus 6 by 3. So, you observe that a1 by a2, b1 by b2, c1 by c2. All these values are different from each other. So, here we get a1 by a2 is not equal to b1 by b2 is not equal to c1 by c2. Understand? We have to compare the coefficients of the given pair of linear equations like this. If we get like this, that means if a1 by a2 is not equal to b1 by b2 is not equal to c1 by c2, then we get an intersecting lines. Okay? The intersecting lines for the given equations. So, here we get like this. If you draw the graph for this pair of linear equations, definitely we get two lines. They intersect each other at a point like this. Okay. So, here the two lines intersect at a point, only one point. So, we can say that there is only one solution for the equations. Why? Because we get intersecting lines at only one point. So we can say that the solution of the given equations is only one. There is only one solution for the given equations. And this type of equations, what is this type? Where a1 by a2, b1 by b2 and c1 by c2 are not equal to each other. Okay, in any equation, pair of equations, such pair of equations are called consistent equations. Okay. Did you understand? So, in any pair of linear equations, if a1 by a2 is not equal to b1 by b2 is not equal to c1 by c2, then we can call them as consistent equations. We have only one solution for such pair of linear equations. The lines which we get from those two equations are intersecting lines. They meet at only one point. So, we have only one solution. Okay. Now, let us have one more pair of linear equations like this. 2x plus 3y is equal to 9. Now, 4x plus 6y is equal to 11. Now, let us compare the coefficients in this pair of linear equations also. Now, what is a1 by a2? Is 2 by 4. 2 by 4 means you will get 2 1 2 2 we get 1 by 2. And what is b1 by b2? the coefficients of y, the ratio of the coefficients of y is b1 by b2, that is 3 by 6, we get 1 by 2. Okay, and what is c1 by c2? c1 by c2 is 9 by 11. Here you can observe that a1 by a2 is equal to b1 by b2, but not equal to c1 by c2. Okay, in the previous case, in the above case, we get all are not equal to each other. a1 by a2 is not equal to b1 by b2, and these two are not equal to c1 by c2. We get like that. So we get the intersecting lines. Now in this case, we get a1 by a2 is 1 by 2, b1 by b2 also 1 by 2. So a1 by a2 is equal to b1 by b2, that is not equal to c1 by c2. Okay? So in this type of situations, we get parallel lines. If you draw graph for the given equations, definitely you will get parallel lines. Okay? A pair of parallel lines, parallel lines never meet at any point. So we can say that there is no solution for these equations. Okay? Here we get parallel lines, so there is no solution. We can say there is no solution for the given equations. In this situation, we call the equations as inconsistent equations. Okay? If the two lines meet at one point, that means if the lines are intersecting, we can call them as, the given equations can be called as consistent equations. Okay? Here we can call these equations as inconsistent equations. Okay. Now, let us go with the third case. Now, let us take one example. Okay. Now look at this. Let us compare the coefficients in this one also. What is a1 by a2? a1 by a2 is 3 by 9. By cancellation we get 1 by 3. And what is b1 by b2? Here b1 by b2 is the coefficients of y. We can say 2 by 6. In cancellation we get 1 by 3. Now what is c1 by c2? c1 by c2 is equal to the constants, ratio of the constants is 7 by 21. We know that 7 3 is 21. So we can write 1 by 3. Here you observe, we get a1 by a2 is equal to b1 by b2 is equal to c1 by c2. In this case, we get all the ratios a1 by a2, b1 by b2 and c1 by c2 are equal to each other. Okay? In this situation, we get coincident lines for the given equations. Okay, coincident lines means they meet each other. They will coincide each other. There will be no gap in between the two lines. Okay, when do we get such type of lines? Whenever the ratios between x coefficients and y coefficients and constants, that is a1 by a2, b1 by b2 and c1 by c2, if they are equal to each other, definitely we will get coincident lines when we draw graphs for the given equations. Now, when two lines meet each other, they coincide with each other, we will have infinite points in contact. They meet each other, so they will have infinite points in common. So we can say that there will be infinitely many solutions for this type of equations. Okay, and these type of equations we call as consistent and dependent equations. Okay, if you understand the difference between these types of equations, we can solve and we can draw the graphs for any type of pair of linear equations very easily. Okay, let us recall all the points once again. Now in the first case, we have two equations. In these two equations, we get a1 by a2, b1 by b2, c1 by c2. a1 by a2 is not equal to b1 by b2 is not equal to c1 by c2. Okay, in this type of pair of linear equations, we get intersecting lines while we are drawing graph, and the intersecting lines means we have only one solution. Okay, such type of linear equations are called consistent equations. In the second case, if A1 by A2 is equal to B1 by B2 is not equal to C1 by C2. See, here we have taken one example. We get parallel lines like this. Okay, there will be no solution if you get parallel lines. Why? Because there will be no common points among those two lines. So we can say that there is no solution. Okay, such type of equations are called inconsistent equations. And now look at the third case. Here I have taken one example. 3x plus 2y plus 7 is equal to 0, 9x plus 6y plus 21 is equal to 0. In this we get a1 by a2, b1 by b2, c1 by c2. All are equal to each other. Okay. In this type of pair of linear equations we get coincident lines. Okay. So in this situation we get infinitely many solutions. Why? Because those two lines meet at every point. Okay. So here we can say that there are infinitely many solutions. This type of equations we call as consistent and dependent equations. Understand?